Sorry, I was muted. Welcome everyone tonight. Thank you for your patience. But praise God, we solved the technical issue, and we're so blessed tonight. We have Warren. He holds a PhD in microbiology from Curtin University, and we worked together before in Adventist Health Association. And thank you for accepting our invitation, Warren. Uh, can I ask you if you can give a quick introduction about
Sure.
yourself and your ministry? Thank you.
Good. Just a correction, my PhD is from New WA.
Oh, sorry.
That's all right, no big deal. But I started my career as a microbiologist at UWA, and then Curtin made me an offer which I couldn't refuse. So I finished up there. And when I retired, I decided that I wanted to be hanging around a bit for my kids and my grandkids. So I took a lot of interest in health, and also my spiritual journey also impressed me that I should look into my health so that I could be of more use and be healthier. So I've specialised in lifestyle health issues since my retirement. I then was appointed the health director for the West Australian Conference, and then in 2019 I retired from that, and no one seems to think that I have retired. So I've been busy doing health programs at high schools at the moment, and that's mainly what I'm doing now. And every now and then I get asked to give a talk, and so that's what I've responded to tonight.
Praise the Lord. And you're just a perfect example of what a healthy lifestyle can do to you.
Hope so. I'm hoping I'm practicing what I'm preaching.
Amen. Thank you.
Now, what have you got up there now? A question mark.
Just let me know if you want the next slide, then I can click on the next
Question
slide.
mark is just purely was put up there because that's what I always look when I get that. I know that my technology is working. So let's move to the next slide. My title, now something's gone wrong here. I don't know why it's different on my computer to what you've got. It should be a capital S. That's a minor thing, but it's the guts of health. Now, what do we mean when we talk about, it's sort of a crude expression, what do we mean when we say the guts of it? We mean the nitty-gritty, the essence, the central factor, don't we? That's what we're talking about. And that's what I want to talk about tonight, the guts, the central factors, the nitty-gritty of health. And you won't believe this, but it's actually, a lot of it's in the gut. Well, it's not the gut really, it's what's in the gut, and that is the microorganisms. And so I'm actually be talking about microorganisms primarily, the microorganisms in the gut. We now know that microbes are foundational to our health. As some of you have, Benji's just mentioned, I'm a microbiologist, and so you will say, obviously he's one-eyed because he thinks microbiology is important. This is true to a point, but when I was still lecturing at Curtin, I used to give introductory lectures on gut health, that is not gut health, but the microbes in the gut, and how it varies with diet and those that cause disease. And we had to define what was normal. And this is where things have changed. We used to dismiss the microbes in the gut as just waste material, but because sometimes pathogens get in there and they cause disease, and we have to know how to distinguish between the pathogen and the normal, what we call the normal flora, the normal microbes in the gut. And suddenly what we've found now is that what we thought were all the bugs in the gut, the microbes in the gut, there's a lot more than we knew. And this is because of new technology. So that's what I really want to talk about tonight, where we stand with this now. The next slide, please. I've just talked about that. Move on to the next one. So what do we mean when we say the guts of it? I've just mentioned that. Now, what is the gut? It's part of the gastrointestinal tract. So the gastrointestinal tract starts up here in the mouth, the esophagus, the stomach, the duodenum, then into the, where are we? The jejunum, and then the ileum, then into the colon. Now, the gut is sort of a general term, but mostly when people talk about the gut, they're talking from the stomach down, okay? So the next slide, please. So the gastrointestinal tract is the esophagus, the mouth, and then what we define as the gut. The next slide, please. The stomach, small intestine, appendix, large intestine. So that's basically the gut, and that's what we'll be talking about tonight. Let me just catch up. So in the next slide, please. Now, this is interesting. The gut has 95, it produces 95% of the body's serotonin in the intestine. Now, serotonin, as you know, is the feel-good hormone, and it reduces anxiety and depression. And we used to think that most of that was produced in the brain, but it's actually produced most of it's produced in the intestines by the nerves there. The intestines actually have an unimaginable number of nerves. These are different, and this is quite different from the rest of the body. We're now wondering if the brain is the absolute rule of the body. Only the brain has more diverse nervous system than the intestines. We now call it the gut brain because of that. The next slide, please. What we call the gut brain axis. This is via the vagus nerve. The vagus nerves runs from the brain to the gut. Now, when we say we get butterflies in the stomach, that's the brain telling us, you know, we're nervous or we're scared, and our stomach goes in a knot and starts acting. Or we're fearful and we soil our pants, or we say an event leaves a bad taste. So that's all the information going from the brain to the gut. Now, also that vagus nerves conveys from the gut to the brain. We say we get a gut reaction, and the brain, the gut tells the brain what we ate, what immune system is doing, and what is in the blood, etc. So there's this two-way communication. We'll just have a quick look now. The next slide, the stomach. I'm not going to give you a big talk on digestion, but the stomach, just a minute. I'm sorry. Just had a bit of a glitch here. The stomach, I've got to catch up, Benji, just a minute. The stomach, as you know, continues the breakup of the food from the mouth. It also breaks down protein and a few other nutrients, and that passes that then through into the next. The time food spends in the stomach depends very much on what kind of food. If you've got carbohydrate, it's only about 2 hours before it passes through. If you have protein and fats, it can be up to 6 hours. So you'll understand why I'm saying that in a minute. Then the contents, what we call the chyle, moves down into the small intestine. The first part is the duodenum, then, as I said, the jejunum, then the ileum, and the whole intestine meanders for 3 to 6 meters. So we have the next slide, please. And this shows you how it's packed in. So here's the duodenum, and here's the jejunum, and then down here we have the ileum. Now, the next slide, please. Let's look at a bit more of the construction. Here is the intestine. It's highly folded. Okay, and each of these folds have all these little, what we call villi. This is where all the food and nutrients are absorbed. And then here's one of these villi, and the villi then have these little microvilli, which is 1 cell thick. And this is where all the absorption happens. And we'll move on to the next slide, please. Oh, here we are. Now, if you unfolded all that small intestine, it would be 18 meters long. Can you imagine that? And every 1 square millimeter has 30 villi, and remember the villi have microvilli. So it's pretty amazing, really. Next slide, please. And here just shows you a villus, and here are the microvilli. Here's the bloodstream coming through. Glucose and amino acids. Amino acids are building blocks of protein. They're absorbed into the bloodstream and goes to the liver where it's all processed. Also down the middle is what we call a lacteal, a tiny lymphatic vessel, and all the fats, or the correct name of fatty acids and glycerol, they're absorbed into that, and they go into the lymphatic system, and then are emptied eventually from a lymph duct in various places into the bloodstream. Next slide, please. So if we flattened everything in the small intestine, it would be 30 square meters, which is 100 times the amount of surface on the skin, of all our skin. And when it gets into the food, gets into what we call the chyle, into the small intestine, it continues to break down the food. So carbohydrates are broken down into sugars. Protein is broken down to amino acids, and this goes to the blood, to the liver. Next slide, please. The fats are broken to fatty acids, and as I said, go into lymphatics. It takes about 6 hours for the protein and fat to clear, less time for CHO is carbohydrate, for carbohydrates. Now, this is an important thing. When it finishes passing all this on, then it cleans itself, much like a kitchen, you know. My wife prepares the food, then she goes and cleans up the kitchen. That's exactly what the small intestine wants to do. But if you, just go back, if you eat something, a message goes down the vagus nerve and says, hey, get ready, there's food coming. And so it stops the cleaning process. So what's that telling you? You need to give the small intestine a fair go to clean itself before you start eating food again. All right, next slide, please. Now, the appendix. Next slide. Next slide, Benji. So this is the junction. Back again, please. Here is what we call the vermiform appendix. It's just sticking here, and it's where the ileum of the small intestine joins into the large intestine, the ascending colon, transverse colon, descending colon. Next slide, please. In the past, we believed it wasn't important. I remember as a kid, if there's any doubt, you yanked the appendix out. And when I went to uni, I remember the evolutionists saying, the appendix, we don't know, you know, it's a waste of time. What's it really important for? It's the vestigial remains of our evolutionary past. That's changed now. It is now called the gatekeeper of the large intestine. It's a reservoir of good bacteria, and it monitors what's coming out of the small intestine into the large intestine, and it responds accordingly. Next, some further down, it's associated with lymphoid tissue. Now, lymphoid tissue is important in immune function. So it really is very important. It has a very big role to play in immunity and also a reservoir of good bacteria. Next slide, please. Now we come to the large intestine. It's about 1.5 meters long. It has billions of bacteria. And in the past, we believed these weren't important. we believed it was only to excrete the smelly waste products that we were producing. But it's far more important than that, we now know. And it has been extensively researched. Next slide, please. It's often called the forgotten organ. Let's have a look and see what we now know about it. First of all, the microbes in the large intestine break down what hasn't been digested in the stomach and small intestine. We know that there's absorption of calcium, magnesium, and zinc. And some of the bacteria, if you've got the right bacteria, let's say the good bacteria in your gut, they'll produce B1, thiamine, B2, riboflavin, and some of them produce B12. And that's a very interesting point. I want to spend a little bit of time on this because a lot of people say, well, we all know that if you're on a vegan diet, you don't get any B12 and you've got either take a supplement or you need to take a supplement. Now, some people may in fact have enough of these good bacteria which are producing enough B12 to keep the body going. That's why some people, when they stop taking B12 or having a source of B12, it's a long time before they start showing anemia. And it might be, I believe, because they've got good bacteria in their gut which are producing B12. Another important vitamin that the bacteria produce is vitamin K. And what we now know is, and this is new to all new information, good bacteria also produce what we call short-chain volatile fatty acids, SCFA. Things like acetate, propionate, and butyrate. We know that these are important because they alter chemotaxis and phagocytosis. They induce reactive oxygen species. They influence cell proliferation and function. And they also are anti-inflammatory, anti-tumorigenic, and they have antimicrobial effects. And very important, they affect gut integrity. They make the large intestine is one cell thick, and these SCFAs produce very tight junctions. Whereas if we're not getting enough of these in our diet, of the bugs that produce this, those junctions between the cells become loose and stuff leaks out of the intestine, large intestine, into the body. And of course, that's dangerous. What have you done there, Benji? Yeah, so what affects micro? You hear a lot of people talking about the microbiota. What is the microbiota? The microbiota is the bugs in a certain environment. If you've got a fish pond, it'll have a microbial microbiota, okay? And so we talk about the microorganisms in our gut as the microbiota or microbiome. So what affects this? What determines what kind of microbes we have in our gut? First of all, birth. Now, this is another interesting point because you know that women often get urinary tract infections, and the very wise say that's because the vagina is so close to the outlet for the urethra. And so, you know, that's why the anus, I'm sorry, is so close and you get infection. But it's a very important thing because as the baby is born, there's microbial organisms around the anus and the vagina, which when the baby's coming out, it picks them up, and that's where it gets its microbial microbiota from the mother, from the colon in the mother's natural gut flora. And then, just to go back, a lot of people now are being born by cesarean section, and they've now found a link Because if you're being born by cesarean section, you don't get any of your mother's colonic microbes from the colon. You only get the bugs that are on her skin. And so they've now found that children born by C-section are at greater risk of cardiovascular disease, are more likely to be overweight or obese. And what's worrying is that the number of babies having C-section has risen from 18.5% in 1990 to 36% in 2019. This was a large longitudinal study done by James Cook University in rural and remote health and the University of Queensland. Next slide, please. So what else influences whether a baby is fed by breast formula? Also, if you're on antibiotics and some medications can adjust the pH, which will affect some of the bacteria. But antibiotics you take for an infection, it's no respecter of persons, and all these good bugs in your gut will get wiped out. And we've known that for a long time. There's nothing new about that. But we now know also that stress is a very important factor in what kind of microorganisms you've got. And I don't understand why, and I don't think it's been explained yet, but they've found a correlation between exercise and good bacteria. Now, these bacteria in the colon, they exchange genetic information. And that's a very interesting thing too, because you've probably all heard that there is a lot of microbes which are now resistant to antibiotics. And if you ingest those, they will pass on their genes to the resident bacteria. And we know a lot of that occurs. Next, please. I've highlighted diet specifically. You'll see why in a minute. Next slide, please. And the particular part of diet that's important for the good microbes is fibre. There are three types of fibre. There is the insoluble. This is a mostly bulk fibre which the body can't use, and that's what makes up most of the fecal material. But that insoluble fibre is very important because it initiates peristalsis, which gets rid of the feces. We all know that. I think everyone knows that if you can't defecate, that fibre is important, and that's the insoluble fibre. But there's also the soluble fibre, excuse me, which feeds the good bacteria. That's what they like. And it's these good bacteria that affect our health and metabolism. Then we have resistant starch. Similar to insoluble fibre. Have you ever made porridge and then left it overnight and the next morning it's all jelly? That's resistant starch. But once again, it's another form of starch which the good bacteria like and which they need. The modern diet, as we know, is very low in fibre. That icon left, Benji. Now, the studies they've done have found the average Australian has about 1,000 to 1,500 different species or kinds of microbes. And they've found that people with what we call metabolic syndrome, that is, people have, it varies a little bit on definition, but basically you're obese, you have high blood pressure, high blood triglycerides and high glucose, low levels of HDL and insulin resistance. So people who have three or more of these are said to have metabolic syndrome. And they've found that people who have metabolic syndrome have less species of microbes than people who are more healthy. Next slide, please. Continuing on fibre, they've found that primitive people, I put a question mark That's what these studies call them, primitive people. What they are is people who haven't come in contact with Western civilization. So they're primitives, they say, but they may have more knowledge than we even realise. They found that there were two societies which they looked at. One was in Africa, the Hazda people in Africa, who were still living as they used to. And then they found in 2009 the Vanomami in Venezuela, right in the Amazon jungle. And they haven't been in contact with civilization at all. Now, the interesting findings that they found is that they have in their diet 5 to 10 times more fiber than we have. But the interesting thing was they had 2 to 4 times the different types of microbes than we have. They even had microbes which we didn't even know about. So they didn't have any of the modern diseases that we have. Next slide, please. Next slide. Now, what's the role of the microbiota? The microbes in our gut breaks down products the body can't digest, which we've just talked about. It helps exclude pathogens. Any pathogen, if it wants to infect, it has to, excuse me, it has to compete with the normal bacteria in the gut. What happens is bacteria to survive in the gut, otherwise they just go out in the feces. They have to have an attachment site to grow and multiply. And so pathogens have to attach too, but if all those attachment sites are taken up by good bacteria, they don't stand a chance. And also, to survive, they have to compete for nutrients. And they don't like the nutrients that the good bacteria have. But the other thing also, the good bacteria produce antimicrobial substances related to antibiotics, which kill other bacteria. So they help exclude the pathogens. And they also stimulate the host to produce antimicrobial substances, which I won't bother dealing with for now. Yes. Now, let's look at some of the effects that we know that the microbiota play. First of all, obesity. Now, here are two rats out of the same litter, and we can see the difference between them, can't we? But the interesting thing they found this was, I think in 2006 from memory. If they took the feces from this mouse and replaced the feces in this mouse with the lean one's microbiota, this mouse got slim. And if they did the vice versa, and took the fecal material from this mouse or rat, it is in this case, and they replaced the fecal microbes in this one with the microbes from the fat one, this lean one got fat. So they begin to realize how important the microbes in the gut were. If we can have the next slide, please, Benji. So these are some of the other effects that they're related to, and I haven't got time to give you all the references. If you want them, I can get them for you. They found the type of microbes or microbiota we have in our gut, particularly our large intestine, affects heart disease, it affects cancer. We all know that some diets are very carcinogenic, and that's relating to the microbes. Mental health can affect anxiety levels. What they did, they took the gut flora from an anxious person and put it into an animal's colon, and the animals started to get anxious. We also know that the type of microbes you have can affect behaviour. they found that, and this might sound a bit cruel, but they took two types of mice, equal numbers, and they put them into water, which they couldn't quite touch the bottom with their paws to swim. And there was one set of mice just had the normal flora. The other set of mice, they gave them a strain of Lactobacillus rhamnosus JB1. Doesn't mean much to you, but that particular microbe they put into the gut flora of the other set of mice, and then they started the experiment, and they all started swimming because they didn't want to drown. But the interesting thing was the normal mice just gave up and drowned, or they didn't let them drown, but they just sunk to the bottom. But the ones that had this particular Lactobacillus rhamnosus strain, which isn't normally found in mice, all those animals kept on swimming longer. They had a greater will to survive. Another experiment they did was looked at personality changes with gut flora. They took I used to work in a laboratory in my school holidays, university holidays, which did tests on animals. And I found this out very clearly because we would have to look after the animals they're doing tests on, mice and rats. And some strains of rat were very placid. You could just pick them up and weigh them and they wouldn't complain. The other ones would try to bite you and were very aggressive. So what they did, they got an aggressive rat or mice, I don't remember which it was, doesn't really matter, and they took the fecal material from that animal and replaced the fecal material in a placid animal, and the placid one became far more aggressive, and they did vice versa. They took the feces from the placid mice and put them into the aggressive mice, replaced their microbes. I'll tell you a bit more about that later. And the aggressive ones became much more placid. So very clearly, the type of microorganisms does affect personality. Now, this is interesting. A study done in England just a while ago studied vegetarians and compared them with a matched group of meat eaters, and they found that the vegetarians had more even moods than the people who were heavy meat eaters. They've also found the type of microbe can affect depression, and also you've heard of irritable bowel syndrome. It can also affect irritable bowel syndrome. I was giving a talk on the microbiome once, and this lady was sort of very agitated in the front and was putting her hand up. So I thought I'd better stop and see what's wrong. And she said, I just wanted to tell you that I used to have irritable bowel syndrome, and I changed my diet on advice. And now I know, and I had a very strict diet, and I no longer have irritable bowel syndrome. We also know that the type of microbe in your gut modulates the immune response. 80% of our immune system is in the gut. So how important is that if you want to resist disease? Next slide, please, Benji. We also found a correlation between multiple sclerosis and gut flora. There is also a genetic one, of course. I have a friend, and his wife has got multiple sclerosis, and she went on a very strict diet, and she's in remission at the moment. She has some residual effects, but she isn't getting worse. Also, they found it's related to asthma and arthritis. Sleep, very important. The type of microbes we have in our gut affects our circadian alignment. If we have an unbalanced flora, which we can moderate by diet. I talked about the metabolic syndrome, and I just gave you that information a bit earlier. Next slide, please. Did you miss something on the last one, Benji? Chronic fatigue is the other one. They've found the type of microorganism affects chronic fatigue syndrome. Next slide now. Now, some very important studies were done actually in Holland. And this guy was trying to find out about the microbiome and studying it. And he was able to grow a very small amount of this organism. And he found it was related to, in your gut, if you had it in your gut, you had a healthier metabolic status. You were more likely to not have a weight problem. You were more likely to have reduced glucose intolerance. And he found it was associated with healthy gut bacteria. If you had this microorganism, the rest of your gut flora tended to be much more healthy. And he was able to grow just a very tiny, small amount of it, and just enough to work with, but not enough to produce commercially so we can give it to people. And he found it was very important in breaking down mucin. And so his name was Ackerman, so he called it Akkermansia muciniphila. In other words, phyla is to love mucin. And what he found was that this organism, which he associated with all these things, was boosted by a low saturated fat diet, a high omega-3 content, and also if the diet had fructose, oligosaccharides and inulin, lactulose and polyphenols. Next slide, please. We seem to have missed a slide. I'm wondering whether I sent you the right PowerPoint. I had a draft one. I had altered it, Benji. So just before we move on to this, just go back. So how do we know about any of these bacteria? There's a slide missing somewhere. We now can do genetic sequencing, and we can sequence microorganisms and you've heard of fingerprinting? You know, they identify someone who was involved in a crime because they've left a fingerprint and they've been able to identify the genetic material that they've left behind. It's the same as these microorganisms. If people had told me when I started my career and my lecturing about some of these things, I would have laughed. But we've now found out that we only knew 70% of the microbes that were in the gut because we couldn't culture the others. We still can't. And being able to culture this Akkermansia muciniphila and using DNA fingerprinting, we can then do DNA fingerprinting and see if that DNA is in a sample. And they've now done this with many microorganisms. So you can take a bit of fecal material and you can look for all the genetic material there. You can go onto a website and identify, say, oh, that genetic material belongs to this microorganism. Is that clear? Next slide, please. So obviously we need to have a good microbiota. So how can we do that? Some people take probiotics. What are probiotics? They're live microorganisms which, when we administer them in adequate amounts, confer a health benefit on the host. But it's important. These are limited to bacteria we can grow and supply. If you have a look on some of the probiotic bottles, it'll have lactobacillus species, bifidobacterium species. We can grow these by the bucket load and put them into a tablet for you. But most of the bacteria that we're talking about associated with health, we can't grow. We can't grow Akkermansia muciniphila in large numbers, so we can give you a tablet, all right? Next slide, please. You can go into the shops and get all these probiotics, okay? But we can't give you a probiotic for 70% of the bacteria in the gut. All right, next slide, please. So that's probiotics. The other one is prebiotics. What are prebiotics? Prebiotics are the food components that induce the growth or activity of beneficial bacteria, microbes, like Akkermansia muciniphila. It likes glucosaccharides, as I mentioned, inulin, polyphenols. So if we feed that, then if people eat those in their diet, Akkermansia muciniphila will like that, and we now know that other bacteria will like it as well. Next slide, please. So we now know that these prebiotics are favoured by the good bacteria. I've already mentioned the fructo-oligosaccharides. There's also galacto oligosaccharides, polyphenols, inulin. I've mentioned that twice. Resistant starch, pectin, beta-glucans, xylo-oligosaccharides, polyphenols. And there's also a big market for these. Next slide, please. So here are all the prebiotics you can get, you can see some of them are. Inulin, see here, inulin, and all the different prebiotics. Next slide, please. So where are all these prebiotics found? Where do they get them from? You guessed it, from fruit and vegetables. Next slide, please. So the safest and most natural way to improve the microbiota is have fruit and vegetables. Have a wide variety. Keeps this, and you need to have a diversity and balance because they interact. We now know that some of these very important products in fruit and vegetables, although they're good by themselves, they actually interact with each other. So together they're far more, they're what we call synergistic. They're far better than just each one by themselves. So it's also the cheapest way to go. Do you see the price of those prebiotics? You think that fruit and veggies are now expensive. I can tell you it's much cheaper still to go and use fruit and vegetables as your source of prebiotics. Now, is this a good way to go? Notice this statement. The manipulation of the gut microbiota is complex and may cause bacteria-host interactions, which we don't want. In other words, by feeding the body the prebiotics or probiotics, we distort the balance in the gut. It's a very delicate balance, but we're distorting it and favouring one type of microorganism over the other. Next slide, please. Now, the other way you can improve your gut microbiota, you can have a fecal transplant. And you can do this if you go to St. Vincent's Hospital in Sydney. Dr. Brody there is doing fecal transplants. So what they do is they get a healthy person, they check them, see they're healthy, but they're lean, and they've got these obese patients who want to lose weight. So what they do is they treat the obese patients, so they get rid of their microbiota, and they replace that with a fecal material from a lean person. And that person that was obese will lose weight as long as they keep those good bugs. To keep the good bugs, they have to provide the right food, fruit and vegetables, otherwise all that good will not happen. And I understand, I have heard, and I haven't checked it out, there is someone in Perth who might be doing that. I don't know for sure. So, but you don't have to do that. Just change your diet and your exercise, your lifestyle, and you'll have the right microbes. They'll gradually take over and be beneficial. If you don't have them, you may have to have a fecal transplant. Now, notice here the dietary guidelines issued by the government of Australia. Most Australians need more vegetables and fruit, particularly green, orange and red vegetables. Variety, such as broccoli, carrots, capsicum, sweet potatoes, leafy vegetables like spinach, legumes, beans like and beans like lentils. So there's the legumes, beans and lentils. Grains, particularly whole grain cereals like wholemeal breads, whole grain high fibre breakfast cereals, oats, whole grain rice, and pasta, whole grain pasta. All the foods that the good microbes like. Next slide, please. Now, there's nothing new about this. Notice what Hippocrates said. He lived from 1460 to 370 BC. He is quoted as saying, "Death sits in the bowels, and bad digestion is the root of all evil." How insightful was that? Our food should be our medicine, and our medicine should be our food. A wise man ought to realize that health is his most valuable possession. Next slide. So why should we be interested in the microbiota? Because we'll have better physical and mental health. And our motto is live better longer. What's the point of living to ripe old age if you can't enjoy it? So living better longer is our motto. And also there's a spiritual dimension to it. Whether therefore you eat or drink or whatsoever you do all to the glory of God. For you are bought with a price, therefore glorify God in your body. So before I finish, I think we missed a slide back there somewhere, and I just wanted to let you know that how important the microbes in the gut are. There is more genetic material in the microbes in the gut and in the whole of our body, far more. And do you know that the feces, I can't remember the figures, have, let me see if I can bring it up on my computer. There are microbes right through the gut, but the most of the microbes are down in the large intestine. And so our feces are made up of a very high percentage of microbes. Now, how are we going for time, Benji? I'm sorry I wasn't watching the time.
Oh, yeah, thank you, Warren. That was really very, very informative. Can we open it? Are you finished? We can open it now for any question from our viewers.
I can't guarantee to answer them, but I'll try.
Yeah, so you can write it on the chat, or you can unmute yourself and ask the question. So we've got viewers on YouTube Live and also here in Zoom. That was really good information, Warren. I have a question.
Yeah.
So with a bacteria transplant, microbe transplant, is it possible to have to identify certain bacteria to produce an immune response so that we can target a certain disease like COVID-19?
No, you can't, basically. It's an
Okay.
overall stimulation of the immune response. You can't target it. It's just a general, for some reason which we don't fully understand, these good bacteria stimulate our immune system, just like a cold shower stimulates your immune system, you know.
So is it possible that we are deficient in good bacteria?
Well, the problem is, what did you start out with? Were you born by C-section or by normal birth? Because they now know very when the microbes of its mum's flora. So the important point there is that it's basically your mother hands on to you good bacteria or bad bacteria. So how important it needs to be for the mother to have a good diet so that they have the right microbes. And there's another factor which comes into it these days. We're almost too hygienic. Kids out and play out in the dirt, and they'd pick up good bugs there. And everything is so sterile these days, so that you don't pick up some of these good bugs, because we're all terrified of picking up the bad bugs. I'm not saying be hygienic, don't get me wrong, but if you don't inherit good bugs, I don't know enough about it in this respect. Now, we do know that if you change your diet, you change completely your microorganisms. If you're a meat eater, for instance, you have proteolytic bacteria. If you have a high animal protein, even from dairy, it stimulates what we call proteolytic bacteria, and they're the bad ones because they like protein and break it down. Whereas the good bugs are what we call saccharolytic. They like polysaccharides. And so what I'm coming at is, if you change your diet, do you have any residual good bugs there which can be stimulated to grow? And we don't know that. But we do know very clearly that if you change your diet, you do get a benefit. But we don't know to what effect that changes a person's microbiota at this stage. Does that make sense?
Yeah, thank you. There's a question from YouTube viewer. Is kombucha beneficial?
Well, I don't see anything wrong with it. How can I put this? I'm a little bit wary. I mean, let me put it another way. Kombucha and tempeh and all that have been used in Asia for years, and it seems to be beneficial. So I don't think it's harmful. But I'm always a bit worried about distorting the normal microbes in the gut. But if you don't have any very good bugs in your gut, I think kombucha would be good for you. Yes.
Thank you.
But just on that, what I often say to people, I said you've got to be very careful about taking probiotics because it might distort the delicate balance in your gut. What I do say to people, and this relates to kombucha, is that if you've had an infection, you've been on antibiotics, your gut flora would have taken a hammering. And so I often say it's a good idea to go and have some probiotic like kombucha or tempeh and all that, whatever, for some time afterwards. So at least you're getting some good bugs in there. All right.
Yes. Thank you, Warren. I've got a question here from someone who's taken antibiotics. So he understood that antibiotics can kill the gut microbiome. So how? What steps should he do to get the good bacteria again? Because it might be killed with the antibiotics he's taking.
I virtually answered that just then. I would, when you finish the course of antibiotics, and you've got to have them, and it's better to get rid of the pathogen than to get sick and even die. I always, as I said, I suggest that for probably a week or so after you've stopped, start taking some probiotic. Okay. So you get some good bugs in there. It's better to have those than nothing at all. and help establish that some good bacteria in there again. And when you do that, if you go for a probiotic, have a look at one that's got the largest number of different types of microbes in them. Some of them
Okay.
have 2 or 3 or 4 different types. Some of them have, I think one of them has about 20 different microbes in them. So the more, the merrier.
Mm.
You've got a good
Uh,
cover. Mm.
would you be able to culture some of your good bacteria by using your hands in preparing food? For example, if someone went through antibiotics and he would ask, oh, but let's look at the assumption first. The assumption is, let me know if the assumption is right or wrong. If you're in the same family with the same diet, does that mean that you have similar kind of microbiome?
Well, certainly as far as your mother's concerned, but not necessarily as far as your father's concerned. Because remember, you inherit your microbiota from your mother.
Mm.
Yeah, so often we say, oh, I'm fat because you've heard people say this. They say I'm fat because they can't help it. It's genetics. It probably isn't genetics in many cases. What it is because you've got the same bugs and eating the same food. You follow me?
Yep. Yep.
Mm.
All right. Thank you, Warren. There's another question here from YouTube viewer. My grandson has autism and has avoidant restrictive food intake disorder. Would probiotics, etc., be of benefit for him?
Sorry?
Autism.
Said?
This is
You said something?
my grandson has autism. Would probiotics be of benefit for him?
Well, it won't be any harm, let me put it that way. I mean, we're talking about a very complex situation in the gut, and they have found a correlation between autism and microbiota. But when you need to start that, I don't know. But yes, I think it's worth trying. It could be quite beneficial.
Okay.
Mm.
There is a statement here from
Just
Tara.
before you go on, but
Yes.
there's no point in taking microbiota or having fecal transplants unless you change your dietary pattern, because they'll just disappear and go out. They'll die off. Sorry, go on.
Yeah. Because you won't be able to feed them.
No.
Right. There's a statement here. There is a trend now in obstetrics to seed babies born by cesarean section by using a swab from the vagina or rectal swab.
Mm-hmm. Yes, I think that's probably a good way to go.
Okay.
Mm.
So if you're, is it true that you can ask your mom to prepare a food with her hands? Will that transfer some of her microbiota into the food, and you eat the food and you get that replenishment instead of taking probiotics?
Not necessarily, because the bugs on your skin are not the same as the ones in your gut. They're
Okay.
yeah, unless she's gone to the toilet and hasn't washed her hands.
Might be a problem with pathogens also if you don't wash your hands.
That are lurking there, in which you haven't yet had any symptoms from.
I've read somewhere, Warren. Let me know if this is correct. The best way to support your microbiome is have your own organic garden, use with your hands. So you're working with the soil, and the produce from the garden that you work with your own hands will support your microbiome.
Well, I don't have any problems with that. Excuse me, my throat's playing up. you know, because so much of the food we buy these days are sprayed heavily, and you know, you've got to wash them very thoroughly because we don't know what all those herbicides and insecticides are doing to our microorganisms.
Okay. If there's no other question.
I have a question, Ben.
Yep, Brother Noel.
Warren, I have a question. How does the balanced microbiome look like? Is it 50% good bacteria, 50% bad bacteria, 50% proteolytic, 50% saccharolytic? How does it?
But
How
sorry, it depends
does the balance
completely on what
look?
your diet is. Does that make sense? It completely depends on your diet. You're saying what's the normal ratio? Well, what's normal, we don't really know, but we do know that diet, if you're having a good diet, it will, it's definitely, the preponderance will be saccharolytic. And by the way, I should tell you this, if you want to know a bit about your gut flora, there you can go online and they'll send you there's a company particularly up in Queensland, and like you do for screening for colon cancer, they'll send you a kit and you send them back a little bit of your feces and they'll analyse and tell you what bugs you've got in your gut. You'll pay for it, of course.
Yeah. Because I've heard that it's not only good bacteria, but you need the bad bacteria as well. Is that true?
Well, I don't know what the evidence for that is. I'm sorry. I don't know everything, but I can't understand what that reasoning is. I mean, when you say bad bacteria, they may not be necessarily good in every respect as far as we're talking about, but there will be other bacteria there. The important thing is having the bacteria which will make available things like the short-chain fatty acids, which are so important we're finding there. That's the important thing of having enough of the good bacteria to do the good things.
Yeah. All right. Thank you.
What was the name of the company, Warren, to get a gut flora test?
Remember, I'd have to look it up for you.
Okay.
So they're doing a microbiome mapping.
Yes, they do at the microbiome mapping, and they sequence all the DNA in your feces, and they go into a database, and we now have a very extensive database, and they say, oh, that bit of genetic sequence, that's E. coli, and this bit of genetic sequence is a Clostridium something or other, you know? Yeah.
All right, thank you.
All right. Thank you, everyone, for joining our webinar tonight. And double thank you to Warren for sharing his knowledge for us about gut science.
Do you want me through the company for you? I'll email it to you or message
Thank you,
it.
and I'll share it with everyone. Okay.
I'm sorry, we just noticed we somehow missed 2 slides, but never mind.
Okay. We will get Warren back on the 30th, so don't miss that in 3 weeks.
Had enough, Benji.
Sorry.
Might have had enough.
I'm sure you had a lot to share with us, so we'll grab that opportunity. Don't miss our webinar next week. We will have Dr. Eddie Ramirez. He's a research director of WIMAR and also a health director now in one of our conferences in Pennsylvania. Yeah, let's close with a prayer. And thank you so much, Warren. We'll see you back again with our viewers in 3 weeks on the 30th. So mark your calendars.
Yeah.
All right. Let's have prayer. Our gracious Heavenly Father, we thank you for the lecture tonight about God science. And we thank you for Warren for sharing his knowledge with us. And thank you for the good night's sleep tonight. In Jesus' name we pray. Amen.
Just to answer that person's question, I'm sorry, I just thought of